In this lecture, we're going to be going through each of the key climate regions of the world. And you should prepare yourself. This is a little bit of a longer lecture. And I strongly recommend that as you look at this lecture and you think about climate regions, you spend a bunch of time looking at the text at each of these regions as well, and using them in concert with the homework to really get a good idea of each of the world's climate regions. We'll come back to this map again and again over the course of the lecture, and you should be using it as well to identify where each of these regions are. We're going to start off talking about the tropical climates, and the key tropical climates are the rainforest climate, shown in orange, and the savanna climates. We'll also talk a little bit about the monsoon climates as well, but they're not as important in the course. Tropical climates are found in places that have really consistent high-quality insolation, as we know. The intertropical convergence zone is very close, but they're often impacted by the subtropical highs as well. Those savanna climates are. Ocean temperatures are quite warm in this area. So we're going to have warm temperatures all year round with very little seasonality. Lots of precipitation, but that precipitation might vary a little bit based on where the ITCZ is or the subtropical highs are. So let's talk about the two key climate types, rainforest and savanna, and then I'll mention the monsoon after this. And we're going to do that by looking at climographs of each of these. Here's a climograph of a place called Uapes, Brazil, or something close to that, which is found very close to the equator in Brazil. It's a classic tropical rainforest. You'll see it receives about 115 inches of precipitation a year. Compare that to the Anchorage Airport that gets 15 inches a year. Even if you take all of our snow and melt it down to liquid water, it's still about 15 inches a year. You'll see by the purple line that the temperature variation is very little. That purple line shows for each of the months that the temperature is just below 80 degrees on average. The blue bars show the amount of precipitation that falls in each month. And you can see that the driest month of the year still gets 6 inches or 15 centimeters of precipitation. The wettest gets over 12 inches. And on average, they're probably getting somewhere pretty close to 10 inches of precipitation a month. The intertropical convergence zone is right on top of this area. It's always warm. It's always wet. It's always impacted by low pressure. We can compare Uapes, Brazil, to a tropical savanna climate. And here's a savanna climate that's shown in Tanzania. Usually these savanna climates are a little bit to the north or a little bit to the south of the equator, depending on the particular one that we're looking at. The really important thing to note, though, is that they have a really big difference in precipitation between the summer months and the winter months. Now remember, we're in the southern hemisphere here, so the winter months are June, July, August, September, October, where this area gets less than 1 inch of precipitation in an average month. During the summertime, on the other hand, it's very wet and moist. It's also a little bit warmer as well because you get more direct sunlight during those warm summer months, and you get more humidity as a result of the intertropical convergence zone being there that helps to retain heat over the course of the night and into the over the course of the day and into the night as well. Tropical savanna climates are known for this really big distinction between a wet season and a dry season. They still have very consistent precipitation, very consistent temperature pattern. And as a result of that, we see a purple line that stays pretty close to the same because the quality of insolation is so high throughout the year. Now, the last of the tropical climates to take a look at is the monsoon climates. They're mostly found in Asia. Asia has a really profound effect on the intertropical convergence zone during the summer months. And in fact, it pulls the intertropical convergence zone so far to the north that actually starts to bend the trade winds. And when those trade winds lift up and over mountainous areas, like you find in Southeast Asia or other parts of Asia, you get the really intense precipitation. You can see that Yangon or Rangoon in Myanmar or Burma gets over 60 inches of 60 centimeters of precipitation on average in the month of August. And in fact, the summer months get so much precipitation that they're sort of off the chart here, literally. These are wet, dry climates, though, usually, and during the winter months, very little precipitation falls whatsoever. The temperature pattern, again, doesn't fluctuate a great deal because we're close to the equator. We have good, high-quality insolation throughout most of the year. A little bit of an impact to temperature as a result of humidity and cloud cover during the summer, but for the most part, things are pretty regular. So these are the key tropical climates. We're going to skip over the dry climates now, which latitudinally come next, and talk instead about the mid-latitude climates. And these are called the mesothermal climates. They're places that get more seasonal insolation, and so they have a real summer and a real winter, though not as profound as we get in northern climates. These areas are very strongly impacted by the polar front and by the westerlies. They get lots of wave cyclones that impact them. Some mesothermal climates are very continental, some are maritime, and we'll talk about that in a bit. They're also influenced by the subtropical highs, at least the latter two are, and that's a really important way to understand why some places are humid subtropical and some are Mediterranean. So let's talk about each of these in turn. The first is the marine west coast climate, and these are places that you find in coastal Alaska in the south, stretching along British Columbia and into the Pacific Northwest, shown in the sort of light green color. The humid subtropical are the dark green colors that are shown in many parts of southeast United States and also in parts of China. And then the Mediterranean climates are not surprisingly found in the Mediterranean, but also in California, also in parts of Chile, also in parts of South Africa, and parts of Australia. Also all the big wine producing areas, if you have not made that connection yet. So on the very left-hand side here, we see the marine west coast climate. We're looking at the southern hemisphere here. This is New Zealand. You can see that it's got a real summer and a real winter. The winter, which are the months of May, June, July, and August, are significantly cooler because there's a lot less sunlight. During the summer months, things warm up and that purple line gets a lot higher. But if we look at the bars of precipitation, you'll see that they're relatively even throughout the course of the year. Regular precipitation coming through as a result of wave cyclones and the subpolar lows impacting this area. The total amount of precipitation is not huge, like a tropical rainforest area. So Seattle complains a lot about the rain that it gets, but the reality is Seattle's not super wet. It just has a lot of rainy days with rainfall, but not significant amounts of rainfall. Now, as we move our way to the east coast of continents, we find the humid subtropical climates, and this one is represented by Columbia, South Carolina. We again see a big fluctuation in temperature between summer months and winter months. In fact, it's larger because these areas have more continental impact. So they get a little bit warmer in the summer, a little bit cooler in the winter, depending on where they are latitudinally. You'll see that their precipitation, again, is relatively even throughout the year. Now, there's two reasons for this. The first reason is that in the wintertime, these areas get regular wave cyclones, subpolar lows coming through, and bringing in regular precipitation. In fact, more precipitation that you often get in marine west coast areas because it's more continental. In the summertime, something strange happens, though. The precipitation actually bumps up. But if you look at the graph, you'll see it says the subtropical highs. Well, the subtropical highs shouldn't produce more precipitation, less, because they're drier, right? But what actually happens in these humid subtropical climates is that the high pressure areas have an impact of pumping warm, moist air from, in this case, the Gulf up and into the continent, where there's a lot of atmospheric instability, and you get lots of thunderstorms and things like that. So the East Coast gets a lot of these big thunderstorms during the early spring and summer that brings regular precipitation. Now this is quite different from the Mediterranean climates that are shown over here with two climographs, one for San Francisco and another for a part of Spain. You'll see there's not as much temperature fluctuation, especially for San Francisco, and that is in part because it's a very maritime climate. We've been here before, right? Maritime versus continental when we compared it to Wichita. But what you'll see that's really significant about Mediterranean climates is that there's almost no precipitation during the summer months. And that is because the subtropical high, which pumps moisture into these areas in humid subtropical, blocks that moisture on the west coast of areas, of continents. And so we get very dry conditions, desert-like conditions. Now, as we move our way north, and these climates don't actually exist in the southern hemisphere, we get more and more seasonality because we get really big swings in insolation. And we start to get to cooler climates as well because the insolation quality isn't very good. These are the microthermal climates. They're strongly impacted by the polar front and westerlies and wave cyclones, but also sometimes by polar air as well and the cold, high pressure that comes in the north. They mostly have pretty strong continental influences, and they're effectively two kinds. There are humid continental, which are a little bit farther to the south and found mostly in the eastern part of continents, but in Europe in particular, they creep into the west as well. And then the subarctic ones, which are farther to the north. And that includes most of south central Alaska, in fact, most of Alaska overall. So let's take a look at some of each of these. So here we are looking at the humid continental climates. And this is New York City right here. This is a city in China. And you'll see much bigger swings in temperature and much cooler temperatures compared to what we saw before as well. So New York can get pretty hot in the summer, but it does get cold in the winter. Its average temperature actually dips below freezing, and there's snowfall. You'll see that precipitation is distributed all throughout the course of the year, and that's in part because of cyclonic storm tracks, but also summer convection, just like we saw in the humid subtropical climates. Now in Asia, the winters tend to be a lot drier, and that's because Asia is so continental, it cools conditions down a lot more, especially in the continent, and it robs the regular cyclonic storms that come through the area of a lot of moisture. Moving farther north to Churchill, Manitoba, which is at a latitude very close to Anchorage, we see that the temperatures have really big swings over the course of a season. Now, it gets colder in Churchill than it does in Anchorage, but it also doesn't get quite as warm as Anchorage. It's a little bit cooler, in part because you get the cooling effect of Hudson Bay. But there are these big fluctuations that we see here. It's continental. Anchorage is a little bit more maritime. But this is because we're farther north and we have really big differences in the total amount of insolation that comes in the summer versus the winter. And in the winter, of course, there's very little. Regular precipitation over the course of the year, but not very much precipitation. There are regular cyclonic storms and wave cyclones that come through. But because these areas are dominated by continental air masses and very cool temperatures, they tend to be a lot drier. And in south central Alaska, we know that we get slightly more precipitation than what we get right here in Churchill, Manitoba. As we move our way out of the more maritime locations, conditions do get relatively dry like this in Alaska as well. So these particular areas are shown by these blue colors, light blue for the humid continental, and then the darker blue for the subarctic areas. And now we're on to the polar areas, which include both the tundra climates and also the ice cap climates. These are areas with extreme seasonal insolation, very low humidity. And as a result of all the Arctic high pressure that we have in these areas, they are very dry and very cool as well. They do have warmer temperatures in the summer, but because the quality of the light is so poor, they tend to be relatively cool. And these include both the tundra climates and also the ice cap climates. The ice cap climates are not found where people live, so I'm not going to show an example of this, but for the tundra climates, I'm going to show you Verkhoyansk, which is a climate station in Russia, which is actually pretty famous. You can see huge fluctuation in the temperature. In fact, it has, I think, one of the greatest ranges in temperature fluctuation for an inhabited area in the world. And then very low amounts of overall precipitation as well. Now, the next areas that we're going to look at are the desert and the steppe areas, and they are shown in these sort of brownish and yellow colors, both in North America, in parts of South America, Africa, and Australia, but Northern Africa and Central Asia is where we have the most of these areas. They are found in these areas for two reasons. Number one, subtropical highs influence these areas, especially the lower latitude areas, the ones closer to the equator, where the subtropical highs dominate. But continental effects are very important in arid climates as well, because orographic effects essentially wring moisture out of air masses, so by the time they get to the middle of great big continents, they're quite dry. That rain shadow effect that we talked about before. Aridity means that temperatures do fluctuate a lot more than they might otherwise do, because arid climates have very little moderation whatsoever in temperatures due to a lack of moisture. There are a number of different climate types in the arid areas, but I think what's really important to differentiate are the desert areas, where the amount of precipitation that falls is what it says here, half of the natural moisture demand, and let's put demand in air quotes here. That refers to the amount of moisture that is essentially used up by the environment through evaporation and also the transpiration of plants. In the steppe climates, there's a little bit more precipitation than that, so it's greater than half of that natural moisture demand. And these steppe climates are places where we get grasslands, essentially. Now, both of these climates have low latitude and mid latitude. The low latitude are the ones that are closer to the equator, closer to the subtropical highs. The mid latitude ones, also impacted by the subtropical highs, but usually impacted by continental effects as well. So here are a couple of examples of the desert ones first. Here's a classic low latitude desert in Saudi Arabia. You can see pretty big fluctuation in the total amount of insolation, leading to pretty big differences between summer and winter temperatures. Very little precipitation because of the subtropical highs dominating. Over here is Albuquerque, which is a mid-latitude arid area. Again, big fluctuations in the temperature. Again, profoundly quite dry area because you're in the middle of a continent, and so little moisture can make it to New Mexico. On the far right-hand side here, we are taking a look at two steppe climates. These are climates that are both mid-latitude steppes. We could also have low-latitude steppe climates, but these are the great grassland areas of the world. A little bit more precipitation, especially given the fact that the temperatures are cooler, so there's less evaporation that takes place in these areas. Big swings in the overall temperature, relatively dry areas, able to support grassland areas, unlike the desert areas. So these are all the world's key climates. Took 20 minutes, sorry for that. You will have to spend some time working through the book to understand these more, but hopefully some of this discussion has helped you.